Okay, guys, Blackboard, I don't know what the deal is. I don't think it's going to work, and class is almost over, and you guys may have other stuff to do. So I'm just going to finish this in a screencast, and then I'm going to post it to my YouTube channel. I'm going to email it out to you guys. So the density calculation that we were doing, remember, we need the answer in grams per centimeters cubed. We have the volume here in millimeters cubed, so we need to convert to centimeters cubed. We have the mass in kilograms, and it needs to be in grams. So we need to do two conversions before we start. So 550 millimeters cubed. See how this pen works so much better when screencasting as opposed to Blackboard Connect anyways. Times, and this is how I do my conversions. I think I did this last time a little bit. You can do them a different way. This is how I like to do them. So we need to cancel the units, and we need to get centimeters. So if you were looking at the steps from the previous slide, you know that centimeters is one step above millimeters. So 1 centimeter is equal to 12 millimeters cubed. Now, since we have millimeters on the bottom, millimeters cubed on the top, we can cross those out, and then we're left with centimeters cubed. Then you just multiply across the top, multiply across the bottom, and then divide. And there's nothing on the bottom here. You can think of it as over 1 if you want. So multiply across the top, 550 divided by 1, 10, sorry. 1 times 10 is 10. So that equals 55, and then we said we crossed out the units, we have centimeters cubed left. Now the other way to do this, you know that you're going up 1 step from millimeters to centimeters. You're going up 1 step, right? If we went back here, we'd go, if we're going from millimeters to centimeters, we're going up 1 step. So you remember every step you divide by 10. So if you wanted to think of it that way, you could do that also. You could just do 550 divided by 10 because you know you're just going up 1 step. Now we need to, where'd my pen go? 2 times 10 to the 5th kilograms. And we need to go to grams. So if we're doing it my way, which is faster if you can do it this way, I know I need to go from kilograms to grams, and I know that there is, in every 1 kilogram, there's 1,000 grams, right? And I put kilograms on the bottom because I want to cancel that out. It's on the top, right? So kilograms on the bottom, kilograms on the top. Cross them off, we're left with grams. Multiply across the top, multiply across the bottom. So I get 2 times 10 to the, should be the 8th, over 1. 1 times 1 is 1, so it's just 2 times 10 to the 8th, and we're left with grams. And now, the rest of it should be easy, right? Because we know density equals m divided by v, or mass over volume. We have our mass in grams now. We have our volume in centimeters cubed now. We can just plug it into our density equation. Density equals mass 2 times 10 to the 8th over our volume, 55 centimeters cubed. This is, sorry, you guys can recognize 2 times 10 to the 8th. And then we get our answer. You could plug that into your calculator, and then you would get the answer. Okay, so make sure you know how to do density calculations. Make sure you know how to do density calculations. Last thing I want to go over here is physical properties changes, and then chemical properties and changes. So physical properties are properties you can see without changing the chemical nature of the substance. Examples are mass, volume, shape, color, magnetism, boiling point, freezing point, all that kind of stuff. And a physical change is when a physical property about a substance changes while maintaining the same chemical composition. So a physical change might be when you heat an object, it changes color, and then it returns to its original color when it cools down. Or phase changes, like an ice cube melting would be a physical change. It's still water. The chemical composition, that's the important thing, the chemical composition, the chemical nature of it hasn't changed. It's still the same chemical formula. It's still H2O, right? If you heat an object and there's no chemical reaction that takes place, sometimes there is, but if you heat an object and you maintain the same chemical formula, then it's a physical change. As opposed to a chemical change, where produces matter with a different chemical makeup than what you started with. So that's the key here. A chemical change is a different chemical makeup. The chemical formula would change in a chemical change. And chemical properties are just characteristics related to its ability to interact with the substance. Important thing to know. Chemical change, different chemical makeup than it was started with. Example there is anytime you burn something. Anytime you burn something, it changes to a different chemical formula. So for example, a lot of things like methane would be this, plus to burn things you always need oxygen, and that forms CO2 plus H2O. This is a combustion reaction. There's always O2, there's always CO2 and H2O in the products, and this right here would be your fuel. So this is methane. You can put propane in there, you can put butane. And so this, see, we get different. There is no more methane after combustion happens. It's changed into CO2 and some of it goes into water. So that's a chemical reaction. We have a different chemical formula after it happens. And then I have a little video here that I want to share with you guys. I think it's kind of funny.